Cell lysis is a critical step in biomanufacturing. Depending on the cell type, products can be produced inside the cell, and in order to extract and purify those products, the cell will need to be lysed or broken so products can be released. There are two main ways cells can be lysed: mechanical and non-mechanical. Mechanical methods include pressure-based systems such as the French press, sonication, and less commonly bead mills. Pressure-based systems can be non-continuous or continuous. The non-continuous systems consist of a stainless steel pressure cell which holds a finite amount of liquid. This pressure cell is comprised of a cylinder with a stopper at one end and a plunger at the other. The cells are pressurized when the plunger is acted upon by a mechanical press. The cells are forced through a small outlet opposite a surface. As the cells escape the nozzle, there is a local drop in pressure, and the cells impact the surface, causing shear forces which break open the cell. Continuous units work in a similar fashion, except a pump constantly forces material through the nozzle. To perform any of these processes, the cells must be resuspended into an appropriate buffer. For most systems, the ratio of buffer to wet cells is between 3 and 5, meaning for every 1 gram of cells, you need 3 to 5 milliliters of buffer. We use E. coli in this class for most lab exercises. Cells must be completely resuspended in order for efficient lysis to occur. Clumps of cells could cause clogging in pressure-based systems or lower product yields in sonicators. Sonicators generate a lot of heat, so when processing cells, the units are typically used in a cold room, and the sample should be iced. There are two ways to operate a sonicator: semi-continuous or pulse mode. In semi-continuous mode, the sonicator runs for a specific amount of time, and cells are allowed to cool down. In practice, we would use 30 seconds on and 1 minute off. In pulse mode, the sonicator is on for a very short amount of time, say 1 second on, and is off for 1 second, and then cells rest and cool down between each round of pulses. Depending on the volume of cells, you may need more or less time to achieve optimal lysis with minimal impact on product yield. There is a balance where if you sonicate for too little time, you won't have a lot of product, but if you sonicate too long, then you could heat denature your protein. There are many manufacturers and models of homogenizers. In our lab, we use a constant systems homogenizer. It has a touchscreen operation and can achieve 40,000 psi pressure. The system has a hopper where a material is loaded, the pressure cell, and outlet. Again, you will want to ensure you have well resuspended cells before getting started, and the material should be chilled down in an ice bucket. The pressure cell can also be chilled. We use a standalone chiller to cool down the pressure cell. You should give the system at least 1 hour to chill down before getting started. Once the system is ready, first run some water through the system to make sure it was cleaned after the last use. Once you're confident the system is ready, then decant your cell slurry into the hopper and press the start button. The machine automatically starts. You will hear the material being pulled into the system, and then it is forced into the pressure cell and comes out the outlet. After a single pass, the cells are mostly lysed. This can be tested by plating out the material and counting the resulting colony-forming units. We typically pass the material through the system a total of 3 times. After you have lysed cells, the material should be further processed to remove cell debris and unbroken cells. This is typically done using either centrifugation and/or filtration, which are covered in other units of this course.